Okay, one more video before your Thanksgiving break. Please remember that you have your reflection that I absolutely need by Monday morning so that I can read and write my final comments before I give you your credential. Well written, proofread, all of that stuff. Must get that in by Monday morning. If you don't, that's a soft skills grade that you don't want to lose. Anyways, for tonight, you're dealing with arcs and central angles, as well as some arc lengths and sector areas. Should be pretty straightforward. The homework is to basically do the odds for the arcs and central angles problem. And then when you get to the arc length and sector areas, instead of doing the odds, do the ones where it's in degrees instead of radians. So I'm going to scroll through it if you want to see what I'm talking about. Right, so anything that had pi could have been translated into degrees. I'm actually going to be using those for my teaching examples. You can have the other ones ready to go. When you're doing this, it does say to leave your answers to the nearest tenth. I would actually request that you keep it in terms of pi, simply to get used to that skill. Punching it in a calculator is always something you can do, but I want you to be comfortable either way. Now, here's the basic idea. Anytime you're talking about a circle, let me do that with an actual piece. Right. So title for your notes should be right, so that's kind of our title. Now, I should remember that going around any given circle is 360 degrees, right? Now, the two formulas that you had earlier in the week is that the area for a circle is going to be pi times the radius squared, and the circumference, which is the distance around, was 2 times pi times the radius. Those are the two that you're using for the majority of this. Now, from the center, this is a central angle, specifically referring to the angle on the inside. Okay? If I want a sector, I'm referring to basically the piece of pizza that it makes. And so if let me make my pizza red, right? If I'm shading all of this in, right? This is my sector, which is area. Angle is going to be in degrees, and arc is a part of give you a chance to copy all that down before I tell you what in the world we're talking about. Okay, so I have an arc, which is a part of the circumference. I have a sector, which is a piece of pizza basically starting in the center. Right? Okay. Now, a segment, which we're not going to deal with too much today, is if I took a chord, which means not through the center, this one's a little bit more complex, but I want you to have it in your notes all in one place. You should kind of get used to that idea. Now, just as a super crash coursey thing, when you end up doing this later, right, the segment will basically end up being like a sector minus a triangle, right? So later I'll be like, hey, here was this whole sector, which is what you're going to learn to solve for today. You'd use some trig to take out that sector, and what's left over would be your segment. Again, not doing that part today, but I want you to know what the heck a segment is, right? When it comes from a sector, it's just a part of the area. Now, both of these are all going to basically be a percentage, a fraction, a ratio of your circumference or of your area. Okay, so if I'm talking about a sector, I'm going to grab that area formula. If I'm talking about an arc, I'm going to use my circumference formula. But what I'm going to do on both of them is I'm going to multiply it by the fraction, which is the part over 360 degrees, right? Where the part is whatever your theta is. Right, so I have a fraction, okay? Take a moment, copy this down, then I'll show you what in the world I'm talking about. Okay, so I'm scrolling over here. Now, in this particular piece, also going to point out there's two different types of arcs. There's minor arcs and there's major arcs. Minor arc, quite literally, is just the shortest distance between 2 points. So I would have HI, and I put a little arc symbol above it. Now, if I want a major arc, it means I want you to take the long way around. So if I want the long way around, so angle 1 is here, which means I'm starting at B, going to A, but I want the long way around. Minor arc is 2 letters. Major arc is 3 letters, where the first and the third are where did I start, where did I stop. So I know I started at A, I know I'm ending at B, but I want you to go through C in order to show that here's my A, I'm going around through C, going to B. If all I said was AB, it would be that shorter piece. That's the difference between a major arc and a minor arc. Now, when it comes to distance, circumference, I'm just saying find the measure of the arcs or the central angle, right? And it says if it looks like a diameter, it is. If it looks like a radius, it is. So the points in the center are there. And it says it wants this arc here, right? Now, if I'm going all the way around a circle, it's also 360 degrees. So quite literally, a central angle is going to be the same as the arc, right? 360 around the middle, 360 at the end. So this is also just going to be 123 degrees. Nothing fancy. Now, getting a little further, if I'm going with SPQ, right, I want to know what is the measurement of this entire angle. I'm going to zoom in. I'm going to remember that a circle is 360 degrees. So if I can figure out what this arc is, I know my angle has to be the same. It actually gives me a whole bunch of information I don't need. Because if I just take my 360, I subtract that 154 and that 60 degrees, what's left over is going to be my yellow SQ arc, which is going to have the same central angle. So if I subtract these two, that'll put me at 206 minus 60, so 144 if I'm not mistaken. If I did my math right, should be there. But I'm hoping you get the idea. Now, that's what I end up having. Now, if, right, I start using some algebra, still going to go through similar pieces where I know my arc is going to be congruent to my central angle. It says that's a diameter, which means those are actually both 90 because they're marked as being congruent. So I just set that equal to 90. I know x has to be a -3 because I'm going to subtract. Right? So central angle's pretty straightforward. When you get back from the Thanksgiving recess, you'll also learn about inscribed angles, which is what in the world happens if it's on the edge. Okay, so that's what you have there. Now, when you're finding arc, length, and sector area, this is what's happening with those pieces I had above. I'm no longer asking you just what it is in terms of angle, but rather, what is the area of this sector? Well, I know the area of the entire circle would be pi times 11 squared, which would be 121 pi. If I was dealing with the whole thing. Now, I only want 315 degrees of it, right? So that means I have 315 out of my 360 degrees. And ideally, you're going to simplify that thing, right? If you end up simplifying it, it goes all the way down to 7/8. By all means, you can use your calculator to help you with this one, but I want to encourage you to solve it in terms of pi. The answer key that you're going to see online will have it in terms of like just generic area rounded to the nearest tenth. That's also fine, but I want you to practice these skills. So I know 121 is 11 times 11. 7 is also prime. So I'm going to end up with something over 8. So 121 times 7 is going to be, let's see, 847 pi, I believe. Right? And if you end up typing it into the calculator, you'll get another answer. But I want to encourage you to do that. Now, these you don't necessarily have to do. Just go ahead and do all of the problems that are in degrees. I know pi over 6 is 30 degrees. You'll learn that in ASM4 or unit circle trig later on. So just do another one as an example. And I'm going to have pi times 13 squared times 30 over 360. So I have 169 pi. That's going to simplify to become, did I do that right? I did do that right. 30 degrees is 1/12 of the circle. So just 169 pi over 12. And again, you could use the calculator to help you out. This is sectors. This is finding how much I have in here. And notice it gives you a unit, so that's inches. So I would have an inches squared. Right? Same thing over here. This would be feet squared. Now, getting into arcs, right? So vocab is important. Oh, I totally realized I just did that wrong because this is actually started off with arcs. Look at me go. If I was asked to do sectors, that would have been perfect. That's what you're going to do on the second page. everything I just did up top, that's what you're going to do down here. Hopefully you can follow that. But up top, I screwed up, barely. I'm still going to be multiplying by that 315 over 360. Only difference is I'm looking for arc lengths. I sincerely apologize. Arcs is the part of the circumference, which means I'm starting with my 2 pi r, which is my circumference formula, times that part over 360. So I have 2 times pi times 11, so 77 times 2. Well, actually, do that whole simplify early, simplify often thing. So I'm going to have 77 pi over 4. I'm going over here, swap that out. This should have been 2 times pi times 13. So 26 pi over 12. Those will simplify. That's 6. That's a 13. So 13 pi over 6. Again, my apologies for not reading the assignment carefully the first time. At least I realized it to help you. But arc lengths is just that piece around. It's the part of the circumference, right? And sometimes you could be like, oh, that's going to be 3/4 of it. So 3/4 times 2 times pi times 13. Simplify those. 6 times 13. I'm going to have 78 pi times 2. Oh, I did that wrong. My apologies. 2's canceled out. 3 times 13. 39 pi over 2. So that's what I'm doing for arc. Sectors, that's where you're using your area formula of the pi r squared. Because every single time in here, I have the parts of the area. Okay, so times the theta over the 360. Whereas up at the top, I have the circumference. I realize that was kind of fast. It is a more straightforward assignment. Give it your best. Watch this as many times as you have to. I feel like I've been talking kind of fast, so if you need to slow it down and put it into, 0.75 speed, do what you have to in order to get this done. Assignment is that for the first one, do all the odds. Second one, do all the ones that are in degrees. Skip the ones that are in radians. Okay? Also study up your other stuff you've been doing for these few days. That's going to be on your in-class pseudo quiz that won't count as a quiz grade, but you should expect to see a couple of those questions on the final. Okay. Be awesome. Don't forget to do your reflection by Monday morning. Take care. Bye.